Okay, so now we are in the week 5. Okay, we are in the week 5, so we will continue our topic on the next lecture, which is solving ordinary differential equations. Okay, you can download the notes in the Putra Blast. Okay, already uploaded the notes. Okay, so then on Wednesday we will have tutorials for the 4 tutorials, and next Monday you will have your first test, which is 12 to 1 o'clock. Okay, without further ado, I continue the lecture. If you have any question, you can just ask and you can discuss. Okay. Okay, our topics for this topic 4, okay, is a solving ordinary differential equations. Okay, this is the chapter of topic 4. It's not sure topic. It should be a topic 4 here, and the topics is solving ordinary differential equations. Okay. So what we'll cover is the general equation for non-homogeneous and linear homogeneous differential equation, equation for non-homogeneous and linear equation differential equations, and ordinary differential equations systems. So this is you can refer to the modern engineering books. This is the page for you to refer and also for you to study. Okay. First of all, it's a linear homogeneous differential equations. So linear equations that arise relatively frequent in the general practice as a linear constants coefficient equations. So this linear equation in which the coefficient of dependent variable is and its derivative do not depends on the independent variable by a constant. Okay, I think I mentioned about the linear equation previously. So in view of frequency with which such equation arise, the fundamental importance of problems that give rise to such equations, it is perhaps fortunate that they are relatively easy to be solved. Okay, so this is demonstrations of solution equation by considering the first of all the second order linear equation homogeneous of a constant equations. So the most general form is something like this, which is a d square x over dt square. This is the second order. Why the second order? Because of the differentiate 2 times here. So this is a linear second order differential equation form. Okay, bx and the rest, b dx over dt plus cx plus c equal to 0, which is your a should not be 0. So now the solution of the first order homogeneous constants is a dx over dt plus bx plus c, means you only have a one time differentiation. So that's why a first order. Okay, whereas your x is equal to a exponent mt, whereas am plus b equal to 0. So in terms of by analogy, try the function of xt equal to emt as a solution for the equation of 10 over 3. So for example 10.3. Okay, so we change this one to xt equal to emt. So automatically what you have is you have your equation become am emt plus bm exponent mt plus c exponent mt equal to 0. So if we simplify it, is the a m squared plus bm plus c exponent mt. So this is a general equation. Okay, previously if you can see here, this one will be second order. So means the power should be power of 2. So the general equation which is am squared plus bm plus c equal to emt equal to 0. Thus, the exponent mt is a solution of equation provided that am squared plus bm plus c equal to 0. Okay. Okay. Suppose the root of this quadratic equations, okay, are m1 and m2. Okay. Then the exponent m1 will be exponent m1 t and also exponent m2t are the solution of differential equations. So since the linear homogeneous equation, the general equation become x t equal a e m1t plus b m1t. Okay, so if you have an answer of root of m1 and m2, so in terms of linear homogeneous, it can be represented as xt equal to a is a constant, exponent m, m1 t plus b exponent m to t. So the real number will be m1 and m2 here, but provided m1 and m2 is not the same, okay? So means you have a different root of m1 and a different root answer of m2, so you can use this equations. Okay, the form of solution of 10.73 just now is the deceptive simples. So we know that the roots are, there is a two different real number. That's one. Okay, the pair of complex conjugate number and repeat root which must be real. So this is the requirement. So in the first case of 10.39, okay, 10.39, this is question based on this equation. In the second case for the root may be written as m1 as a psi plus j gamma, okay, and m2 is psi plus j gamma. So when we change this psi and also gamma real as a real number inside of these equations, so as mentioned, the equation will be x at t, x a exponent, then this is the real number of psi, and also in terms of j vector of t. So same like b exponent psi minus j psi t. Okay. So if xt can be simplified, so exponent psi t, okay, is equal to a j and a negative j. So this one, if we can simplify, we know that this in terms of vector, so it can change in terms of cos and theta, which is a cos psi t plus j sine psi t plus b cos psi t plus minus j sine. So this one can be simplified again. So what it remains is exponent psi t, okay, a plus b cos this one, and j a minus b sine. So this one in 3 point is using a Euler formula, it can be written that a plus b equal to c or j a minus b equal to d. So this one can be simplified to be x t equal to exponent psi t plus c cos negative plus d sine. Yeah. Okay. In the third case, okay, for example, you have m1 and m2 are equal. So means your m1, you get the root word m1 and m2 is the same answer. Okay. So therefore, what we can do, and it can reduce to become x t equal to a exponent kt plus b exponent kt, because of kt is the same, this one and this one is the same. So automatically you can go for c equal c exponent kt. So in this case, two solutions are not linear independent, so we do not have to complete the solution of 10.3. So the complete solution in this case can be obtained by using a trial of solution, which is xt is equal to tp exponent mt. So in order for 10.3 to have a repeat root m equal to k, the constant of time must be such as in the form of this one. Okay, this is the main form. So which is your a constants times the double differentiation minus 2a constant times the first differentiation plus a k square x equal to 0. Okay, so the substitute trial solution into these equations give, if we substitute, give this type of form. So that is pp minus 1 plus 2m equal to 0, these equations, or it can be simplified something like this. So which is this equation is satisfied for all value of t if m equal k and p equal 1 or p equal 0. So hence t exponent kt and exponent kt are two solutions of differential equations. Okay, these are linear independent functions. So the general solution of case 2 equal root is x xt at exponent kt plus b exponent kt is equal to at plus b, then you take out the exponent kt. So can be something like this. The evidence of solution of 10 that arrive from substitution of trial solution different of 10.37 determine the form of solution of letter, which is the equation of 10.3 is important adjunct to the original equations and is known as the characteristic equation of differential 10.73, equation 10.73 is sometimes referred to auxiliary equations. Okay, so as to summarize, this is the most important thing. For the linear homogeneous differentiation, to solve the second order or linear homogeneous and constant differential equations, so this is your main equation just now, the second order. So the first characteristics equation is am square plus bm plus c. So this one is the general form of this one. When you have a power of 2, so automatically we know that the general form will be a m power of 2 plus b m plus c. Okay. To find the root m1 and m2, then there is a then if the two roots are real, okay, if the two roots are real and these things corresponding solutions, we use this method, which is your xt equal to a exponent m1. Okay, your first root is m1 t plus b exponent m2 t. But if both equal to k, then the corresponding solution is this. If your m1, okay, here is a m1 is equal to k, or equal m1 equal to m2, or we can equal to k. So you can use these equations of this one, which is simplification of xt equal to, in the bracket, at plus b exponent kt. But it's a complex conjugates, so you have a psi, you have a plus minus j when they correspond solutions. So you need to use this one lah. Okay, xt equal to exponent psi t, c cos omega t, then sine. Okay. Here we go for examples. You can see more direct. So find the general solution of these equations. So we know here is the equations have a second order linear equation, which is d square x divided by dt square minus 9 dx over dt plus 6x. So from here we can use which one? The first one, this one. Where is your am square plus bm plus c? So automatically we know that am square plus bm plus c is equal to 0. So what is your a is a 1. So what is your m? You can go for m square plus, what is your b? B is 9. Okay, negative 9. So it become negative 9 here. Okay, dx over dt become m and plus 6. C6 equal to 0. So this is the characteristics of these equations in order for you to find the roots. Okay. Okay. So then that's the first step. So when you get this one, you know that this is a power of 2, this is a power of 1, this is x. So when you put the characteristic equation, it becomes am, a is 1. So m square minus b is 9, negative 9, m plus 6 equal to 0. So from this equation, you can find your root. How to find your root? From here, you will get your root is m equal to 4.1 plus minus 1 over 2 square root 5.57. So in decimal point, your m1 is 8.27, m2 is 0.73. Okay. So here you can use this one lah, plus minus square root of b square minus 4ac though. Okay. So then you will get this answer. What is your root of m? So you get the plus minus m, so which is 8.27 for m1, m2 is 0.273. So when you get this one, this will be classified under this form, the real and these things corresponding. So which is your x, xt is a exponent m1, because m1 and m2 are different, so you use this one. So automatically you have x, xt, a exponent. What is m1? M1 is 7, okay, 8.27t plus b. What is m2? M2 is 0.73t. So this is the final answer of general equations. Okay. Okay. So we go for second examples. Find general equation for 2 d square x divided by dt square minus 3 dx divided by dt plus mx. So you need to change this in terms of characteristic equation, which is am square plus bm plus c equal to c. What is your a? A is 2. What is your m? M is square. Okay. What is your b? Minus 3. Okay, minus 3. What is your second one is m? And plus 5 is equal to 0. So this is the same equation as this one. Okay. Once you have this one, you need to find the root of m. What is the root of the equations? So from this one, okay, you can find in terms of the answer of you will get M1 is equal to 0.7 plus minus J 1.39, and M2 is 0.7 minus J 1.39. Okay. Okay. From these solutions, this one will be categorized into this third one. Sorry, this one will be categorized into the third one, because you have a psi and a plus minus j omega. So you use xt equal to exponent psi t bracket c cos omega t plus d sine t. So here, so is xt exponent, what is psi? Psi is m1, m1 is 0.75. Okay, this one is 1, this one j, this one. Okay, so this one side is 0.70. Okay, what is a cos? What is your angle? Will be 1.390. Okay, plus b sine 1.390. Okay, so because you have a complex conjugate number, okay, this is number and also plus minus j. So this is your final answer. Okay, for example, next we find the general solution of this one. So automatically we need first we need to change into of these terms. So am square plus bm plus c equal to 0. So your a is 1, so you have m square plus your b is 6m plus 9 equal to 0. But this one can be simplified to be a factorial of m plus 3. This one can be, from here you can get m plus 3 square equal to 0. Okay, from here we know that our root equation is m equal to 3. So, or you can say as m1 equal to m2 equal to 3. So we can use the k as a constant. Sorry, -3. K as a constant. So therefore, we need to use this method, this one, because it's same. So we use this xt a t plus b. Okay, we use this one. So you get x t is equal to, in bracket a t plus b exponent -3t, because t -3 is m1 equal m2 equal to k, so you use this one. Okay, so when we substitute this one, that's the first general equations. Okay, characteristic equation and general equations. The next step is they give the condition, which is x 0 equal to 1 and dx dt 0 equal to 2. So x 0 equal to 1. Okay, so when x 0 equal to 1, you put it t equal to 0. Okay, for example here, x 0 is equal to a times t is 0 plus b exponent -3 0 times 0. So what happened? You get a b here equal to 1. Okay, this is the first equation you have. The second equation is differentiation of dt dx 0 equal to 2. Okay, so you need to differentiate this one. Okay, when you differentiate this one, when you change, so you will get -3b plus a equal to 2. So you know b is equal to 1, so automatically you will get your a. Okay, a is equal to 5. A equal to 5. So when you get a is equal to 5, you get b equal to 1. You put back in these equations, so you will get your final answer. Your final, sorry. Then you get this final answer, which is your xt is equal to, what is a? A is 5. b plus what if b is 1, exponent what is k is negative t. So this is your final answer. So there is a first steps, you need to change this in characteristic equation. This is the first step. The second step, you need to find the root. Okay, this is the second step. The third step, in this condition, you have x equal to 0. So you need to find the b. The fourth step, you need to find the a. And final step, you need to finalize the answer. Okay. So if you notice in example 10.36 here, the two initial conditions allow us to determine the value of two arbitrary. Okay, we have condition x equal to 1, the x equal to number. So that's the conditions that helps in us to find the two arbitrary constant in the general of the second. So we have thus demonstrate the techniques that will solve any second order linear equation of the equations. The technique extend quite satisfactory in higher order. So as I mentioned, in these questions, not only the general equation that you need to find or the root, you need to solve it. What is your constant of arbitrary A or B and the rest. Okay. Next, when the same trial solution of exponent mt is substituted into p order equations, so it will be something like this. Okay, so it gives a Rice characteristic equation that is a polynomial equation of degree of a, p, m over p, and the rest. So we know from this theory of polynomial equation that such equation has a p roots. This may be a real and complex, or complex with a complex one at theory conjugate place, and the root may also simple and repeated. So these various of possibilities are dealt with just as a second order equations. The only additional complexity over and over above the solution of the second order lies in the possibility of repeated on more than twice. So in this case of the m, okay, if you have a root of m equal to k of multiply c of n, the technique employed above can be corresponded to exponent kt, t exponent kt, t square exponent kt. Okay. Okay. So we go for examples. Find the general equation. For example, here you have not a second order, it's more than second order. So how to solve this one? So automatically we go for characteristic equations. So it's power of 3, so you get a, for example, a and power of 3, so plus b and power of 2. Okay, then it can keep on reducing, become c m plus d equal to 0. So you have extra here, because you start with power of 3 here. Okay, the differentiation of 3 times. So your general equation should be a power of 3, am. So you change this one into characteristic equations. Okay, what is m? A is equal to 1, so you have m power of 3. What is b? B equal to negative 2, m power of 2. What is c? C is negative 5, m. And what is d? Is 6. Okay, so c plus 6 equal to 0. So this is your characteristic equations. From here, in order for us to find that's the first step, characteristic expression. The second step, you need to find the root. Okay, this one is characteristic equation. The second step, the root. Okay, here, from here, you can simplify it to be a factorial of m minus 1, m plus 2, and m minus 3. Okay, you factorize this one, so equal to 0. So automatically, your root, you will get your m1, m equal to, 1, m also equal to 2, okay, negative 2, so, and m equal to 3. So you have 3 types value of m. Due to this one is a real number, okay, that's a second. The third one, you need to find the solutions. So automatically here we know that when this type of equations, so this is a real number, so you get the xt is equal to a exponent t plus b, okay, sorry, okay, it becomes something like this. Okay, the general equation we get a exponent m1 t plus b exponent m okay, m to t and plus c exponent m3t. So this one, what is your a is a constant, exponent, what is m1? M1 is 1, so it become power of t, plus b, what is your m2? M2 is negative 2, become negative 2t, plus c exponent 3, 3t3. This is your final solution of this answer. So you have three main steps. The first step is change to characteristic equations. Okay, if this one is power of 3, you can keep on reducing m3, m power of 3 minus b power of 2 minus c. So if you have 4, it become a. Okay, for example, you have a power of 4 here. So there will be a power of 4 plus b m power of 3 plus c m power of 2 plus d m power 10 plus e equal to 0. So this is your characteristic equation for if you have a power of 4 here. Okay, so then once you get this one, you need to find the root. In this case, you need to factorize. You get three answer of root, which is m1 is 1, negative 2, and 3. So then you need to find the solutions by xt equal to a exponent t and just plug in the equations. Okay, this one, as I mentioned previously, so we have a power of 4 here. So when you have power of 4, automatically your equation, as I mentioned just now, become a m power of 4 plus b m power of 3 plus c m power of 2 plus d m power of 1 plus e equal to 0. Okay, so then you change this one to general equations. So automatically, what is your a? So a is 2, just become 2 power of 4 plus what is your b? B is 3, so 3 power of 3. What is your c? C is negative 22, so it become negative 22 m power of 2. What is your d? D negative 73 power of m power of 1, and negative e is 60 equal to 0. Okay, so you have these characteristic equations at the first step. The second step, find the root. So in this case, you can simplify it, the root, okay, factorize, become m1, m minus 4 times 2m plus 3 plus m square plus m. Okay, so the first one you will get, when here you will get your m is equal to 4, okay, here. Then your m equal to negative 3 over 2. Then the last one, you will get the negative 2 plus minus j. This one you use the plus minus square root b square. Okay, or AC, then plus j. Okay, so you need to get this one. So you have a 3 answer here. Sorry, 3 roots here. So the first and second is a real number. So what happened? Okay, that's the second. The third one, you need to go for the general equations. So the third one, okay, the general equation is automatically x t is equal to the first one is a real number. So a exponent, what is m1? M1 is 4t plus b exponent, what is m2? M2 is negative 3 over 2t. Okay, then the third one, this one is a complex conjugate. So it's a complex conjugate, we need to use these equations. Okay, which is I mentioned previously. So plus exponent psi t, which is c cos this one t plus sine d sine psi t. So you need to change what is your psi is exponent negative 2, okay, negative 2 t c cos, this is 1, this is cos t plus d sine t. So you get the main answer. Okay, so your general equation is based on the real roots. If you have a real number, you need to use this one. If you have complex conjugate, you need to use this one. Then it will be complete. Okay. Okay, we go for another one. This is also power of 4. So automatically, your characteristic equation is a power of 4 plus bm power of 3 plus cm power of 2 plus d m plus e equal to 0. So then you change this one, you will get this answer. Okay, m1 and 2. Okay, this one, characteristic equations. So the step number 2, you change this one to the root, find the root. Okay, so you get factorization of this one. Okay, so this is the first factorization. The second factorization, you get m minus 2 plus times m plus 1 power of 3 equal to 0. So you have here two types of m, which is the first m is m equal to 2. Second is m equal to -1, but it's a repeat 3 times. So automatically, we know that when you find the final general equations, you get x over t is equal to, this one is a real number, okay? So it's only one time, so you can use a exponent 2t, okay, m1t, plus, because this is repeating 3 times, so we can use this equations directly. So it's b t square plus ct plus d equal to exponent. What is your m2 number is -1, so a negative t. So this is your final answer. So there is a 3 main step. Okay, you need to remember this one lah, this summary lah just now. Okay, here. Okay, you need to remember, if a real number, you use this one. If a repetition number or k constant, you use this one. If a complex conjugate, you need to use this one. So if your root have a 3 of this one, m1 for example lies under this one, you need to use these equations. So m2 is equal to same equal to k, you use, for example m3 is equal to complex conjugate, get this one. Okay, I can show you the how to solve the solutions, something like this lah. Okay, so that's an homogeneous differential equations. So it's quite straightforward. Okay, so first step, okay, just to be summarized, first step you need to determine how many the power, the highest number of differentiation. If 4, you need to use these equations. If 3, you need to reduce it. Okay, so the second step, you need to find your roots by factorial this one, then you get the root of m. So going from this root of m, it depends on just now the summary of the 3 things. So if you need to have these 3 things, you need to have the final answer. Okay. Okay, we go for second, linear non-homogeneous differential equations. Okay, just now it's a linear homogeneous differential equations. Okay, for linear non-homogeneous differential equations, so we should have having dealt with a linear homogeneous constant coefficient differentiation. So it's much a groundwork for linear non-homogeneous constant coefficient differential equation is already covered. So we have learned this just previously about the how the non-homogeneous. So you use the constants of L or A, something like that lah, represent the power of the answer lah. So whereas L is a PTH ordinary linear equation operator. So we have seen in previous section 10.2 last week that general solution of this equation takes a form of some particular integral of the complementary functions. So where is your complementary functions? The derivative of equation L x equal to 0. Okay. So hence the complementary function may be found by the method of last section. In order to complete the treatment of non-homogeneous equation, so we need only to discuss the finding of particular integral. So there is no general mathematical theory that will guarantee the produce of particular integral by routine manipulation. Okay, we shall proceed with giving our examples. Okay, so for non-homogeneous equations, so we know that your main equations not equal to 0, it's equal to something answer on the right side. You have a left hand side, okay, and you have a right. Okay, so when you have this type of equations, non-homogeneous, so what you need to do, you need to change the equation in terms of polynomial. Okay, so where is your equation become, this is power of 2, so your xt automatically become p t square because of power of 2 plus qt plus r. Okay, so this is the general equation for non-homogeneous. Okay, so when we direct substitute here, okay, so we substitute this one to this one, okay, automatically we know p equal to 1. Okay, sorry, when you direct substitute here, okay, the first, okay, from these main equations, so we need to determine based on this differentiation lah. So the first equation 2p square is a double differentiation. So automatically you will get the first one become 2p. Okay, this one will be 2p. You integrate, you differentiate 2 times 2p. Okay, plus the second one is q. What is q? Q is 5, but it's a differentiation of 1 time. So it become differentiation of this one. So differentiation of for the differentiation of the first differentiation. So everything will be 2 pt plus q. Okay, what is your r? R is negative 9. Okay, what is your x? X the main equation. So pt square plus qt plus r equal to 0. Equal to the answer of non-homogeneous t square. Okay. So you get this one, this one based on here. This is your main equation. Okay, your main equations. Okay, the first one is double differentiation of this one in terms of t. So you will get 2p plus remain 2p plus q. What is the second equation is 5. Okay, dx dt, dx over dt. You differentiate this one time, dx over dt. This one is dx over dt. This one is dx square over dt square. So you put it here minus what is your constant is 9. The second x is the original x. You put it here equal to your final answer. So this is your polynomial answer. So this is not the finalized because we need to find your constant. You have a constant here, p, q, and also r. So you need to find these constants. So this is your based on here. Okay, based on these equations. Okay, you simplify it, you will get something like this lah. Okay, for example, you get something like this. The first t square is negative 9 pt square. Okay, then okay, this is for in term of t square. So this one in term of t, this one in term of real number lah. Okay, so from here, the equation coefficient of various power of t on the left sides, we classified with the same characteristics. Okay, the equation on the right side. Okay, for example here, t square. We go for the first one is a t square. In terms of t square, what you have on the left side is negative p. Okay, on the right side you have a t square. So you have equal to 1. Okay, so we go for the second in terms of t. In terms of t, on the left side you have 10p minus 9q. On the right side, you have no t, so become 0 equal to 0. Okay. The third one is the number, the real number, any arbitrary or something like that. So it's a 2p plus 5q plus 9 equal to 0. So you have a 3 equations here based on the classifications. So this one for t square, this one for t, this one for the real number. So from this equation, you can find the p, r, and t. Okay, we have a 3 equation, we have a 3 unknown. Okay, 3 equation and 3 unknown. So automatically you have the answer of p, q, and r. So the p is negative 1.1 over 9, q is a negative 10 over 81, r is a negative 68 over. So it's a constant. So then you put all these things in the main general equation just now. Okay. You put it on this main general equations. Okay, this one. So what is your p? P is negative 1.9 t square minus what is q 10 over 181 t. What is your r is a negative. So this is your the answer of the particular integral of the main solutions. So this is another complementary of method 10-point section. So you can put it additional of a exponent negative 5 minus square root of t square to complete these solutions. So we just add this one. Okay, so next find the general equation of these equations. So we know that this one is a first is a non-homogeneous. Okay, when non-homogeneous, okay, in terms of cos 2t, okay, first, we seek a particular integral. Okay, we want to find the main integral, the main general equations. Okay, so in this case, the right hand side is a cos 2t. Okay, on your right side, okay, just now. So we consider a trial, we put it xt equal to p cos 2t. So we should find the left hand side to produce here cos 2t and sin 2t. So the suggestion becomes something like this. Okay, so once you have a, for example, this cos 2t, automatically your suggestion will be xt is equal to p cos 2t plus q sin 2t. Okay, so when we substitute this one, okay, this is your main general equations. Just now, the answer is double integration, double differentiations, okay, plus 5 dx over dt minus 9x. So you differentiate this one 2 times, okay, you will get this one. Okay, this one is dx over dt, 2 times differentiation. So you differentiate this one into this one, you will get dx over dt. This one the general xt lah, general equations. So you put the constants here. So now constant is 5, 1, 5 and 9. So you put it, this is the second derivative. So times 1, okay, so it should be times 1 here lah, indirectly lah. Minus plus 5 times the second derivative here, first derivative here, minus 9 times the xt, equal to the cos 2t. So on the left side, you simplify the left side, you will get something negative 13p, okay, plus 10q cos 2t minus 10p plus 3qt plus sin 2t and equal to cos t. So from here, you can clarify on the left and the right side. Okay, the first side is a cos 2t. Okay, the first is cos 2t. Okay, on the left side, what is a cos 2t here? So this one. On the right side, cos 2t equal to cos 2t. So cos 2t and cos 2t can be divided, become equal to 1. Okay, the second one is sin 2t. On the left side, the sin 2t is 10p plus 13q. Okay, on the right side, the constant equal to 0. Okay, so you have a 2 equation here, and you want to find p and q, which is 2 unknown. So automatically you get the answer of p is negative 13.269 and q equal to 10 over 1060. Okay, so this one you can put it into the main equation just now, which is your xt is equal to p cos 2t, xt cos 2t plus q, plus q sin 2t. So you put it your p, okay, so this one will become negative 13.269 cos 2t plus q is 10 over 269 sin 2t. So this one can be simplified. So you just take out the 1 over 269. So automatically you get the first one. We put it positive sign first. 10 sin 2t minus 13 cos 2t. So this is the similar answer here. Okay, so you have the particular integral lah, the general equation lah. So then this is a complementary. So you can add this a exponent 5, this one lah, in the after. This is called complementary, complementary functions. So you can put it at the end of the day. So at the end of the equations, so you get the answer. Okay, the third one you have dx over dt square plus 5 dx over dt minus 9 equal to exponent. Okay, we have learned first is a real number, second is a cos theta or something like that, the third is exponent. So when you get exponent, okay, in this case the right hand side is exponent t, exponent 40, sorry, exponent 40, 40, since all derivative of exponent 40 are multiple with exponent 40, the trial of p exponent 40 is being selected. So in this case, because of exponent 40, we start with the exponent for p40. So this one will become, we use, in this case because of exponents, we use your main changing exponent is p exponent 40. Okay, so that's your xt lah. But okay, this is your xt. P exponent 40. Okay, we use p, but we use the we check with the first is the first differentiation. So first differentiation of p exponent. Okay, what you can do is like p exponent 40. Okay, for xt. So the x over dt become 4 p exponent 40. Okay, d square x over dt, differentiate second one, we will get 16 p exponent 40. So then we put it here. This is the first second differentiation. This is the first differentiation. So you put it here. So you become 16. Okay, 16 p exponent 40 plus, okay, what is your constant is 5. 5 times what is your first differentiation is a 4 p exponent t 40, sorry, 40 minus what is your constants? Constant is 9, negative 9, negative 9. What is your main x is x p exponent 40 is equal to the exponent 40. So that's why you will get this equation lah. Okay. The next step you need to what we call it equity, okay, between the left and right. Okay, we go for exponent 40. Exponent 40 on the left side. Exponent 40 is everything is in exponent 40, so you can plus 16 plus 20 become 36, minus become 27, p equal to, so this one become something like this lah, 27 p exponent 40 is equal to exponent 40. Exponent 40 can be divided, so at the end you get this one lah. Okay, so automatically you get your p. What is your p? P is equal to 1 over 27. So back to your main equation here. So you get x is equal to p exponent 40, or what is p? 1 over 27 exponent 40. Okay. Then you put the complementary of this one. Then you get the answer. Okay. Okay. So example, just now we showed the non-homogeneous on how to deal with the most of common of right-hand side functions. So you will depends on the right-hand side. Then you will select what is your xt functions. Then you need to differentiate based on the left-hand side to find the general equations. Then you need to find what is your constant of p or q. Then you will get the answer lah, and the final general equations. So each case of trial solution function is chosen to match of the right side. The trial solution function contain unknown parameter which are determined by substitute the trials of the differential equations. So figure summarize. Okay, this one is the summarizations of how to select. For example, your right hand side functions. Okay, the first one, right function is a polynomial of t degree of p. For example, 6t squared plus 4t plus something like that. So you need to use the trial of p t squared plus q t squared per r per s. So which is your coefficient is p, q, r, and s. For example, your right hand side is an exponents. Okay, exponent function, exponent t. So your trial that you use for your xt, this one trial is xt lah, your main xt before you differentiate. So it's p exponent negative 3. Okay, then your coefficient is only 1p. But if your right hand side is a sine or cos something like that, so you get sine 5t, for example, you use this one, p sine t plus q cos t. So your function is p and q. Okay, so it can summarize. So it depends on your right hand side of the equations. Okay. So before that, to just to summarize on this first, how to answer this one. First thing first, you need to know this one. Okay. So then From here, you refer the table. Table. So exponent you use is P exponent 40, for example. Second, you need to write in terms of the form of differentiation. Okay, so for example, the first differentiation, you differentiate this one, the x over dt, or differentiation of 2 times, then plus the constants, and you get the equations. You get the equation. The third, okay, you classify. I call it classified between, for example, exponent 40 on the left side. What is the right side? Is it 1 or 0, something like that? Then you get the constant. The fourth is get the constants. What is P, what is Q, what is R? The final one, get the final equation. So you have about 5 steps to answer this one. Okay. Okay. What happens if the right hand side is a linear sum of more than one of these functions? Then the appropriate trial function is sum of trial function for the terms making on the right side. It can be seen from the properties of linear equations expressed on this below. Okay, for example, you have a linear different operator, which is you have x1. Okay, this is the just now function L xt equal f1t. So what happens? You have a second solution, which is Lx t equal to f2 xt. What happened? Lx and 1 plus x2 is a solution equation. So means your function Lx of t is equal to f1 t plus f2 t. Okay, for example here. On here you have a general non-homogeneous equations, but on your right side you have 3 equations here. You have exponent negative 2t plus 2 minus t. So in this case, we need to find the particular integral since the right hand side sum are exponential and polynomial degree. So we have exponential here, we have polynomial degree here. Okay. So what we need to do here, we need to clarify based on each one. For example, this one we can change to the p exponent negative 2t. Okay, this is based on the schedule. Okay, what is the second one? We call it as a q, it's a normal constant. The third one plus is the rt, for example. Okay, so you have these 3 main equations. Okay, because the first one will become exponent, you put the exponent, the second one become constant, the third one is a rt. So what happened here, you need to put this main equation in terms of this one, same like previously. First find the, we call it as a trial function. Okay, trial function. Function. Second one, we need to find the main equation. Okay, main equations, this one, the equation. So in this case, dx squared over dt. So you need to differentiate this one 2 times. So what you will get? Okay, differentiate in the first time, the 2 times you will get 4p exponent root 2t. Okay, plus 5. This is your constants. Differentiate 1 time. When you differentiate 1 time, you will get differentiate the first one, become negative 2p exponent negative 2t. Differentiate q become 0. Differentiate rt plus r. Okay, minus 9. 9, what is your main functions? Okay, your trial functions is p exponent to negative 2t plus q plus rt. So equal to these functions. Okay, so you get your main functions here. Next step is classify. Okay, so in this case, your main classify based on these 3 things. The first is exponent negative 2t. The second is 2. Okay, 2. The third one is negative t. Okay, so based on these equations, when you simplify, in terms of exponent 2t, you get 5 negative 15p equal to 1. Okay. The second for number 2, constant is negative q plus 5r equal to. Then the third one for t is a negative 9r minus 1. So you have 3 equations and 3 unknown. Okay, so from this one you get the answer. So what you will get here, you will get your P, you find the answer, your P is equal to -1/15, Q is equal to -13/81, and R is equal to 1/9. Then you put it in the main equation here. So you get xt is equal to P is -15 over ni, exponent -2t, minus 13/81 plus 1/9t. So then you put the complementary functions. Okay, you just put it here. Then you get the final answer. The step is same, but it's additional of several combination of exponents, real number, and something like that. Okay, so the solution is of a linear non-homogeneous constant coefficient differential equation of this order higher than 2 follow directly from the method of second order. Okay, as mentioned, the method is almost the same. Okay, by finding a particular integral of the same whatever degree of equations. Okay, you have a degree of 4 or something, you can answer the equation. Start with the trial equations. Okay, so the principle that the solution is constructed from the particular integral added a complementary function requires the differential operator linear, but it's valid for operator of degree. Okay, hence, by completing the solution of higher order non-homogeneous equation only require that the derived homogeneous can be solved that we have learned previously. And one complication that we have not mentioned, this is illustration 10.44. Okay, so this one. Okay, what is your first step? You know this exponent to t. Once the exponent to t, you will based on the schedule. So your trial, okay, number one is a trial functions, trial solutions is equal to xt is equal to p exponent to -2t. Okay, so we know it because it's exponents. So then the next step is what you need to put in the main general form of differential equations. So differentiate this one two times. Okay, so this is your, okay, sorry. From here, you get the PT. So this one is differentiate 2 times, you get 4p exponent -2t plus differentiate 1 time -2p exponent 2t minus 2, 2 is 2, and the xt is p exponent 2t equal to these equations. But here, in this case, when 4 minus 2 become 2 minus 2 become 2 equal to 0 equal to exponents, so there is no solution of p because become 0. This one becomes 0. So from if you find you face these equations, this is not the final answer. You need to a little bit tweak the answer. Okay, how to do it is first, okay, in this equation of 10.44, it lies on the fact on the right side of the equation function there is also solution of equivalent homogeneous equations. In such case, we must multiply the appropriate trial functions, okay, the appropriate trial function which is p exponent -2t just now, 2t, okay, with a t. So because of it become equal to 0, it cannot be answered. We need to modify. We cannot use p exponent -2t, but this one cannot be used. But you modify to p times t exponent -2t. So we don't want it to become a 0. So in order for us to find the constants. So in this case, your new trials is this one. Okay, pt exponent -2t, because just now it's already 0. So you need to modify, you add pt exponent to t. The first one, pe exponent -2. Okay, then you change this one in terms of differential equation. Okay, so now this, if you double differentiate this one, you will get this one. So you differentiate 1 time, you get this one, and this one the xt. Yeah. Okay, from here you simplify it, then you can solve the problems. So you can classify by the form of exponent. This one exponent -2t. On the left side, you get -3p exponent 2t. On the right side, exponent -2t. So automatically you will get your P is negative 1 over T. Then you put back in the general equations, which is your X T is equal to what is P? Negative 1 over 3 exponent negative 2T plus A exponent negative 2T plus B exponent T. So then you will get the answer. So the key point here, you need to change from PT, okay, from here to here. You change from here to here to get the answer. If your first you get equal to 0 lah, okay. Okay. We got example 10.45. Okay, now we know on your right side it become exponent automatically your trial. You can use it. Trial is P exponent T. Okay. So second, we need to find the equation. Okay, in terms of this one. The third, classify in terms of exponent T and the rest, left and right, left equal to right. Fourth, find constant. In this case, P. 5, finalized equation. Okay, so this is the 4th step. Okay, first we go for the trial. So we know this is exponent T. We use our trial is P exponent T. Okay, the first one is differentiation of 4 times. So we P exponent T, we differentiate 4 times, become P exponent T. Same. Okay, then the second one is negative 2, differentiation of 3 times, negative 2P exponent T. The third one is 5, differentiate 2 times, 5P exponent T. Then the constant is negative 8, negative 8P of P exponent T plus 4 exponent T equal to 0. So this is your main equations. Okay, so this one done, this one done. So you need to specify. Okay, in this case, there is no solution of P because of 1 minus 2 become negative 1 plus 5 will become 4, 4 plus 4, 8, 8 minus 8 becomes 0. So this condition you need to tweak. You cannot use this, you need to change a little bit. So because of no solution of P because equal to 0, this one becomes 0. So what you need to do here, you use this, the linear concept. So we use the M4 minus 2M3 plus 5M2 minus 8M plus 4 equal to 0. So you can simplify it factorial. You will get M minus 1 power of 2, M minus 2 power of 4 equal to 0. So your M, you will get M have a here, several here. So the first one is root 1. You use this one. Okay. AT plus B exponent T. The second one, okay, so you will get C cos 2T plus 2 sine 2T. Okay, so on the right hand side is exponent T. So it's the function of corresponding double root of M equal to 1. So the standard trial function of the right hand side, P exponent T must be multiplied with T squared. So when we substitute this one, so you get P okay, from here, P. So you change the equations to the double differentiation T square exponent T plus 8 T plus 12 minus 2P, then the equations plus 5P equation on the right. Okay. So once you have this one, you will get, you simplify, you get 10P exponent T equal to exponent T. So your P is equal 1 over T, sorry, 1 over 10. So your main equation, you put it here, is on this equation of this one. Okay. So what is your, so it become 1 over 10 T square exponent T plus AT exponent T plus C plus sine. Okay. Okay. So for example, just now we have found a general equation of problem with no boundary conditions. So obviously value could be determined by the constant of fit the general equation to given boundary initial conditions. So each boundary condition allow the value of constants to be fixed. Hence, in general, the number of boundary conditions needed to completely determine the solution is equal to the order of differentiation. Okay, so the last one okay, so we have covered the linear, homogeneous and non-homogeneous. The final one is ordinary differential equation systems. So you can refer to subtopic of 10 page 865 to 879. So you need to read by yourself. Okay, maybe I can show you. Okay, from here is page 867, 865. Okay. So here you can read by yourself the application of this ODE lah. So the free oscillations on how the cantilever, okay, or how to calculate, okay. So this one you need to understand because you will given a project, okay, related to applications. So you need to find an application based on the mathematical engineering applications. This one, for example, the second one is oscillation of dam elastics, how it solve it. So you start to understand because it will help you in terms of doing your projects. Okay, so we will finalize when you give your projects. Okay, you have a good project, so mostly. Okay, so this is interelastic systems. Okay, so this is the application in terms of engineering. Okay, in terms of electrical circuits and the rest. Let's start to understand and okay. So for the solving ordinary equations, okay, we have covered two things: the linear one and linear non-homogeneous, homogeneous, and non-linear homogeneous. So I showed you the step how to solve the problem, several examples. So this one is the cover of chapter 4. Okay, we can refer to the books. So I'm taking from the books. So we follow the books. For example, here we follow for 10.8 linear equations. Previously, constants. Okay, this is the topic for today just now. Linear homogeneous constants. Okay, these are examples. So this is some tutorial that you can do it. Okay. So this one. Okay. So for the topic 4, you have covered. So do you have any questions?
No, thank you, doctor.